we were yet to discuss the set methods.
Yeah.
We'll just see some set methods. This one is equal to 1, 2, 3, 1. This is one set. 5, 4, 5, 1. Something like this. So now we can check the set methods what are all available. So here there is, some important things are like difference and symmetric difference. So there are two things. One is difference and other one is symmetric difference. So difference means difference between the two sets. Okay, it should give the difference, the second one from the first one. Okay, so for example, I am saying S1 minus S2. You can see the output 2, 3. So here, whichever is a common part, it will be removed from the first set. Okay. And the rest of the things only from the first set will be given.
Sorry, how difference occur? Can you come again?
Yeah, difference means now I'm making S1 minus S2.
S2, yeah.
Yeah. So whichever uncommon part in S2 that gets removed. For example,
so because 1 and 1 is there, that's why, right? So it removed completely.
Yeah, 1 and 1 is there, that is removed.
So completely removed.
And only the rest of the elements from S1 will be given. Only from S1, not from S2.
Why?
Because S1 minus S2. Okay. If I make S2 minus S1,
then S2 will be given. Okay.
Yes.
So basically, it doesn't do the normal subtraction, just remove if whatever thing is common, it just remove it.
Set subtraction.
Okay.
So I think the same concept is there in mathematical sets also, like that here it is applying.
Okay.
And here we also have something called symmetric difference. The same thing I can do in this way also. First thing is this minus, I can do like this. Okay.
Okay.
So the output will be. And one more thing is symmetric difference. So what will symmetric difference do? It will remove, but it will keep elements from both. It will give equal priority, symmetric.
So basically the common ones will be removed, but rest all
removed, and the rest of the things will come out.
Okay.
And add. So add an element. So just saying element. Okay, let me add one. Okay, so S1 already. Okay, I should add some different elements. So I can add elements. I can remove the elements. Just add and remove.
Okay. Because there is no series, it doesn't matter where it adds, in front or in.
Yes. That's what. In set, order will never matter.
Okay.
Remove subset. Subset also, like you remember in mathematics we have something like this symbol, right? So S is that symbol is not there in keyboard.
I don't remember sets from mathematics.
No problem. So one set is more bigger than the other. So like this kind of things. For example, S2 is equal to, if I say 1, 2, 3, 4. Okay. So now S1 is actually subset of S2 because S1 can be considered part of the S2. Yeah. So in that case, if we want to verify through methods, so we can do like this. So whichever set I want to check for subset, I'll mention S1 dot is subset. S1 is a subset of S2.
Okay.
It will return true. Vice versa, if I do, it should return false because that is a. Maybe better I can say superset. So S2 is a superset of S1. Yes, that is true. Like true. This.
Yeah, correct.
Subset, superset. Like this, we can do like different set operations, union, intersection, and one more thing is important thing is we have intersection and intersection update. Okay. There is a slight difference between both of them. Okay. So S1 dot
intersect, this would be the common value.
1, 2, 3. Okay. Now if I say S1 dot intersection update of S2, okay, now you see there is no output.
Yeah. What is
okay?
it?
Basically, what it does is it will actually update the S1 with the what I can say. It will update the S1 with the common elements. Update is set with the intersection of itself and another. So let us
what
check
do you
for
mean by
S1.
intersection of?
Okay, intersection of itself and another. Okay, intersection of itself and another means we have only the common elements are 1, 2, 3.
Correct.
Okay. Maybe, okay, I'll take good example. S1 is equal to 1, 2, 3, 4. Okay. And S2 is equal to 3, 4, 5, 6. Okay. Now I am saying S1 dot intersection. Still, I think it will still be the same one. Intersection of S2. This will actually create a new set. Okay. S1 dot intersection of S2 will give you a new set with only the common elements. Now I will say S1 dot intersection update of S2. Now I will check S1. Yeah. So now you can see the difference.
What?
Update is set with the intersection of itself and another. Okay. So here S1 and S2 intersection elements are
3 and 4.
3 and 4. And S1 gets changed to 3 and 4. Earlier S1 did not change. Okay, I can repeat the same example.
Okay, so S1 value is got updated, is it?
Correct. Value itself got changed. But if I say just intersection, then it will not change.
So basically intersection is showing the common elements and intersection update is doing update for the S1 itself.
S1 itself, correct.
Okay, with the common value.
So now, with the common value. Now in this case S1 is still unchanged.
Okay.
But if I do this one,
it will
S1
change
gets
to 3
changed.
and 4. Yeah.
Yeah. So the same thing applies for other things also, because we have something like union. There is, I think, I don't know, this is update union or and symmetric difference update. So like this we have some difference update. So everywhere the same logic will apply. Okay.
Okay.
Yeah. Yeah, these are all just the set methods which we can use. We can explore more. And next we'll go for dictionaries. Oh, what happened? Dictionaries. This is there. Okay, dictionaries. There is some link broken. Just. This still existing. What happened to the page? Dictionaries.html. Is correct only? I will not found it is. Then mapping types.
If you have,
okay,
you can directly.
Yeah, there, but it is not somehow the link is broken. No problem. We will take directly that file and do it for now. That file also directly. Okay. So what are dictionaries? Dictionaries are just set of key value pairs. Set means not that literal set. Yeah, we are just saying normal English word set. set of key value pairs with the requirement that the keys are unique. Okay, keys should be unique. We cannot repeat the key. Same like how in sets we don't have any duplicates. In dictionary, we cannot have duplicate keys.
Okay.
And how to create dictionaries? We can create dictionaries by using a comma separated list of key colon value. Key colon value pair. So I can mention D. So this is a dictionary. So it is having okay.
Key value pairs, just like
twice. Okay, so it is anyhow the single one only.
Okay.
Let me copy this. It is more clear. R is not there. It's come by mistake. So D. Okay, so this is having two key value pairs. Okay, this entire thing you have to see as one unit. Whenever you are seeing the dictionary, this is one unit and this is one
another unit.
Yeah. So here key and value, we call this key. This is the value.
Okay.
And next, we can dict comprehension. Again, will come after for loops. Next, type constructor. So dict function. If I use dict function, so built-in function, then also I can create a dictionary. But if I don't give anything, it's an empty dictionary. Or another way to create empty dictionary is this one.
Okay.
Okay. So I can just give the empty braces. So this will work for dictionary.
Okay.
And is dict of this one. So before going to, this is unnecessary. This I have to remove. I'll remove it. And before going to use more of this dict, we have to see what are all the different options. Okay. So here we have totally 3 options. Okay. Class. I mean, don't worry about the class. Take it as just the function. It will take 3 types of arguments. One is keyword arguments.
Okay.
We are mentioning star because we don't know how many keyword arguments will pass. So it indicates that we can pass either 0 or more than 0 like this.
Okay.
And mapping means again it is another dictionary. So you are taking another dictionary and putting inside the dict. And then I can pass the keyword arguments along with the other dictionary. Third option is iterable. Iterable means list, tuple, these kind of things.
Okay.
And again, I'll pass the keyword argument. So these are like, there are different options to try with. So this option is fitting under which one we can see that. So here I'll take this. Okay. So first of all, what is the data type of this one?
This one is a list.
List, perfect. So again, what is the data type of this one?
This one is tuple.
Yes. Now we have a list of tuples.
Yeah.
Okay. Now outer one is an iterable, correct?
Correct.
And inner one is also?
Iterable.
Iterable. Okay. So that condition we should meet.
Okay.
Here, we will return a new dictionary initialized from an optional positional argument and possibly empty set of keyword arguments. If no positional argument is given, empty dictionary is created. Already we have tried that.
Yes.
If positional argument is given and it is a mapping object, okay, mapping object, leave it. Other case, we are taking positional argument must be an iterable argument. Each item in the iterable, this is important. Each item in the iterable.
Why we have left mapping object for now?
Mapping, I'll take in the next example, I'm saying.
Okay.
Yeah. So each item in the iterable must itself be an iterable with exactly 2 objects. Okay. So what is the each item here in this list?
Each item is like foo is 100, bar is 200.
Yeah. So that data type is a tuple, right?
Yeah,
each item is a tuple.
Correct.
And that is an iterable, correct?
Yeah, 2 items are there.
Okay, so we are meeting the condition. Each item in the iterable must itself be an iterable, correct?
Okay.
With exactly 2 objects. So
2 objects, yeah.
Inside iterable is having exactly how many objects?
2 objects.
2 objects. Okay. Outside iterable is not mandatory. Okay, only the inside iterable I can say. So this is still fine.
This is fine, yeah.
Yeah. So this is one way to create. So this is fitting under this iterable case.
Okay.
Okay. Only iterable. We did not pass any keyword arguments yet.
Yeah.
Okay. So let me take the same thing. Copy, paste, and here. Now So now D2 you can see. This is along with the keyword arguments. Okay, equal to 2.
Okay.
If in case, if we are making something like this, we take the same thing. And here I am putting A is equal to 1. Means A is equal to, 4. Means there is a conflict actually. Yeah. In that case, what will happen, you can see.
2 should be created, yeah.
Latest one will be taken. Okay, keyword argument. So the same thing is mentioned here. If keyword arguments are given, the keyword arguments and their values are added to the dictionary created from the positional argument. If a key being added is already present, then the value from the keyword argument replaces the value from the positional argument. See, here, this is a positional argument. Sorry, this is the positional argument, and this is the keyword argument. Okay, so this positional argument's value when 1 gets replaced by this keyword argument's value. So that is what this sentence means.
So basically, the later value it will replace.
Later value will be considered. Okay. Anyhow, keyword arguments will come later. So that is the thing.
Okay.
Providing keyword arguments only works for keys that are valid Python identifiers. So these keyword arguments will only work for the keys that are valid Python identifiers. Means like something like this. A means a valid variable name. B is a valid variable name. Those things will work. Okay. Identifiers, variable names.
Can it be something like C equal to A equal to 4? That is not allowed, right?
No. C is equal to A is equal to 4. That is not allowed. Okay. Keyword means left side key equal to right side word. Something like this.
Okay.
And next mapping thing. So mapping means we should, now we already have dictionary D2. Okay, so now I am saying D3 is equal to dict of. I'll mention the D2.
Okay,
so now you can see what is D3. So it will be exactly like D2. Now I can also do D3 is equal to dict of D2 comma. Now in this case, mapping and keyword arguments. Okay. So in this case, I can give the keyword arguments. Maybe I can say C is equal to 5.
Okay.
So D3.
C was equal to 5 will be, yeah.
So another key value pair will be added at the very end of D2.
Okay.
So then my D3 will be ready.
This is mutable, right?
Yeah, dictionaries are mutable. Okay. You can change. So that's why the original dictionary itself is getting updated.
Yeah.
Okay. And the last thing is first combination, this one. Only the keyword argument. So that also is possible. So I can make D4 is equal to dict of only keyword arguments. A is equal to 1, B is equal to 2, D3.
Okay.
So these are the like different combinations you can try. You can provide keyword, you can provide another dictionary, or you provide a list of tuples like this.
It does support the position, is it?
Yes, position and keyword. First position and then keyword.
Okay.
Whatever comes in the positional arguments, this all will be first taken into the dictionary. Okay. And then after that, the keyword arguments will be taken into the dictionary.
Okay.
So, I mean, these are all the 3 options. We checked all the 3 options. So this text is saying only about that one. If the positional argument is given and it is a mapping object, and dictionary is created with the same key value pairs as a mapping object. Here, what is a mapping object? Mapping object is another dictionary. That is this one, D2. D2 is the mapping object. So same key value pairs of D2 have come for D3. So that is this statement meaning. Okay. So I mean, these are just the different ways of creating the
dictionary. Okay.
Dictionary. Next, indexing dictionary. Ideally, index means there is no index kind of thing, but we will be using the key for getting a value. Okay, we can retrieve or extract a particular value using the key. I mean, I have to update this text. Okay, we can retrieve or extract a particular value using the key from dictionary.
Okay.
What is the syntax dictionary name of key? Square braces again. That's why I said indexing, just to match the terminology. So here we will be indexing with the help of the key. For example, if I want to get D4, I want to retrieve only the value 1. Okay, then I have to give the exact key.
Okay.
Exact key. I mean, we should not just, if it is a string, we have to give it in the quotes. Okay.
We can't give like 0, 1 like that.
No, we can give. You want to give like this, right? So D5 is equal to I mean, we can actually make this way also. So d5 of 0, something like this. Okay, because for keys, all immutables are allowed. So strings, numbers, anything I can take as keys.
Can you put like d4 bracket 0?
No, you are saying like this,
Yeah.
No, it will not come.
Okay, this is not supported.
Key error, na? Key itself is not there. See, in d4 that key is not there.
Key, but it could give the both a and 1 like this, right? The complete
No,
key value.
no.
Okay.
We don't have that.
Okay.
There is nothing called okay, we cannot get like that one key value pair directly. We cannot get, but there is other way. Okay. So, for example, I mean, anyhow, we will cover this methods also. We can see dir of d4. So there are some methods in this dictionary.
Okay.
Items, keys. So if I say d4 dot items, you can see what is coming. So it will give those combinations for you, which you got, whichever you are asking, A1, B2. So it will give like a combination.
Suppose I just want first one then. First one combination.
Only the first one, huh? Yeah. Then you have to actually go over this like a loop. Okay, if you go over this like a loop, then you will get the first one.
Okay, not there's
okay,
no
or
symbol.
Else there is another way. Anyhow, that also we'll be discussing in some time.
Okay.
I'll tell you how we will get only the first one also.
Okay.
And now, okay, and our membership test. Okay. A key error is raised if a key is not found in the dictionary, whatever we have tried just now. Okay, so if at all we are trying with some key that is not existent, then we'll get a key error.
Okay.
And it will clearly mention that which key. So 0 is not found, so it will give that key.
Okay.
And if you want to test whether something is existing or not, you have to give only the key. For example, here I can say 0 in D4.
Okay.
So key, 0 key in D4. I don't see it, so it will return false.
Right? Like if we have to say A in D4, then it will be.
Yeah, then it will work.
Okay.
A in D4.
Okay.
It's true. Okay. So it will see only the keys, not the values. This is applicable only for the keys.
Okay.
Modifying value for a key. So since dictionaries are mutable, I can change the value for a particular key. I can say D4 of, I have to give the exact key equal to 5. Okay. So now the value itself gets modified. There is no slicing here.
Okay.
Only a value, single value modification we can do.
Okay.
Okay. Next, operations and methods for a dictionary. So I can do some operations. Okay, actually I have to remove some things. I'll update the notes. Don't consider this set thing. So we have to use an operator pipe symbol, okay, for the dictionary. So this pipe symbol will create a new dictionary with the merged keys and values of D and other, which must both be dictionaries. Okay, so I have to give two dictionaries on either side of the pipe symbol. For example, let us see what is D3 and D4. So D3 or D4. Okay, so this should be my final dictionary. You can see it will have the, if there are common keys, anyhow, one will get the preference.
Override.
So where there, yes, there is a common key between the first one and the second one.
Yeah.
Okay, the values of the other take priority when D and other share the keys. Okay, what is D and other here? D is equal to D3.
D3 and other is
D4 is the other. So other is taking the priorities because this A and this A, D3 and D4 are sharing the key A, which is having a value 4 and 5. And other is having the value 5. So that will take the priority.
So basically it's like you are overriding, right? The value.
Yes, overwriting. So the previous one will go away. Okay. And there is also another one. Okay, actually I'll update the notes, but I'll explain now. So D3 now see D3 and D4. D3, D4 are not changed. Okay, D3 or D4 is actually returning a new dictionary for you. Okay. But whereas D3 and D4 are still the same. But if I do some other operation like D3, pipe symbol equal to D4.
Okay.
So here now you see there is no output. Whenever you don't see any output means something has happened in the background. Okay. So you can check for D3. Now D3 is changed.
Okay.
It will update D3 with
D4.
The value of the D3 or D4.
Okay.
It is equal to like this. D3 is equal to, if I write D3 or D4, this is the same as the above one, whatever we have written.
Okay.
So this is a shortcut. Whatever we have written above, that is a shortcut. So it will update D3 with the value of D3 or D4. Anyhow, this we will see also in the operators. After the operators also you'll see this again. Okay. But you can correspond this to the sets which we were doing just some time before, like intersection and intersection update were there, right? So here also we are making OR, and then we are making an update for the first one with the OR.
Okay.
And next these all things I have to remove this. Only update, two kinds of updates were there. Yes, that is enough. And next methods. Okay, methods we will directly see here only. So dir of D3. So for example, so there is an update method. So till now we were doing with operators.
Yeah.
D4 is there. So let me make D5. This is one thing. Now I can say D5 dot update of. Okay, I can give directly something else. Okay, I can directly give the dictionary inside this.
Okay.
So here D5 will update with the new key value pair.
Okay.
Same way like how we were doing with the OR equal to operator. Okay, so now same thing. If I want to give D5 dot update of D4, so then it will update with the D4 dictionary. So this is also another way to update.
Okay.
And next is, let us say you want to get only the keys. You are not interested in the values. So then what you can do is D5 dot keys. That's it. So it will return the keys. I mean, the return data type is actually different from the regular list. I mean, it is showing the list format, but it is dict underscore keys. It is like its own type. Okay. So it will return in this format. If you want to make it a list, then just take list of D5 dot. So then it will give a pure list.
Okay.
So then in that case, you will get only the keys, or you can take only the values. So D5 dot values, open and close. Already D5 is the dictionary which will get passed to that value. So it will by default give the values from that particular D5. On whichever dictionary you are calling the values, that dictionary's values will only be given.
So I can call it as tuple of D5 keys as well. So basically,
yes, because this is iterable.
Yeah.
Whichever is iterable, you can put inside that. Sorry, just
keys. Keys.
No, sorry. No. I am actually doing it on top of a function, not the function call.
Yeah.
So if I make it like this is fine, or I can do it for the keys also. It is the same. So I can get D5 dot keys. So both is okay.
Okay.
I can get it into tuple, list.
Okay.
And one. Okay, get something. So I can also use dictionary dot get. So D5 dot get a particular value. Get of, give the key, whichever value you want to get, give the key.
Okay. Python.
Okay, sorry, I gave it Python, so it is not there. So it is not giving any output because whenever the key is not there for the get, what it will do is default value it will return none. Okay, here none means no output. Okay, let us take the successful one first. So here I am getting the value 3.9 because key is found, there's value is 3.9. If I don't get the value and you want to still see some output, okay, because if it's not showing any output, it is confusing if you think. then what we can do is, for the default, I can give some string, key not found. I can mention like this so that other people can understand the error. So in that case, what will happen? defy dot get of. So here I can mention the key not found.
So what this
means we are making it more meaningful with the help of the additional options.
So basically it's returning this key not found.
It's going to return this whenever it is not able to find the key.
Okay.
So in real time, it will be very useful because you can, based on this condition, you will might write some other logic.
Yeah. Okay.
And key items is, okay, items, just now we have seen defy dot items, it will give
all the
both
items,
key and value pairs.
Yeah.
And we can also do clear copy from keys, okay, from keys of other ones. So let us try this one. From keys. So I have to give iterable, create a new dictionary with the keys from either iterable. So, and value will be none. Okay, so value is none. So I can first let us give some iterable. 4. Okay, so everything value is none. Okay, if I want to give same thing with some value, I have to pass in the value 1, 4, comma, whatever value I want to give. So in this dimension. Sorry, what did I do? So I did not close the.
Basically, it has given none because these keys don't exist.
No. Ideally, we are actually creating a new dictionary.
Okay.
So defy dot from keys. Just a moment. So I'm calling it on top of this one. So here. 23, 4. So it is creating with this one. When I'm saying defy dot from keys, I'm creating it from a new, it will create a new dictionary. And I'm calling it with this one, right? So let me try dict dot comes from this one, then it will be better. That it should be dictionary object. If I say there is not. Okay, let me try like this also. 1, 2, comma, value is equal to. Okay, no, it takes no keyword arguments. No, just a second. Dict dot from keys of 1, 2, comma, A. Okay, this one will make more sense because earlier I was just calling on the existing dictionary. Okay, but ideally this will be much better if I am doing it from the what I can say, from the dict built-in itself. Okay, if I'm calling it on top of the dict, then it is like I'm making a new dictionary with these keys, and the common value is this one. Okay. And here it is saying no keyword arguments, though value it is showing is, because what happens whenever you are seeing such kind of things, check for this. So here you are seeing one slash, right?
Mm-hmm.
So whatever, whenever you see that slash, before that everything should be positional only. Okay, though it is being shown as a value is equal to none or something, it is still a positional argument. It is being handled inside the function as a positional argument. So that is why you will not be able to pass like a keyword argument. Okay, whatever comes before the forward slash, everything is positional. You cannot pass like a keyword argument, so you will get an error. So in fact, in the input also you can see. So prompt is equal to is mentioned, but if I say prompt is equal to enter, but it will still give me an error. Okay, input text, no keyword arguments.
Yeah.
Okay, because this is actually, I can say it is more of a description kind of thing rather than the actual functionality.
Yeah.
It is not telling about that it is a keyword parameter you can pass like a keyword. It is just telling that this is a prompt. And the other case, it is just telling that this is a value, but it's not asking you to pass a keyword argument in that place. It is still a positional argument. So how you will recognize? You will recognize with the help of that forward slash.
Okay.
Okay. So we have seen some different things, and you can explore some more things by unpacking. This is, I can say, like very good, and it will be easier to write some real-time programs quickly. So what is unpacking, and like how many types of unpacking are there? We will see. Okay. So, I mean, the same star will play different roles in different places. Based on the context, star will have a different role. So now here star is playing a role of iterable unpacking operator. You know suitcase unpacking, right?
Yeah.
So same thing.
Okay.
So now in this iterable unpacking, so let us take first iterable. So I'm saying L list 1 is equal to 1, 2, 3.
Okay.
So this is my list 1. So it is having 1, 2, 3 values. For iterable unpacking, operator is star, and this star should come onto the left side of the iterable. Okay. So I can mention like this: print star 1, 2, 3. You can see the output. Actually, it is not printing as a list. If I give like this, you can see what is the clear difference. 1, 2, 3.
Yeah, it's not a list.
It's not a list. It is actually unpacking all the things,
okay,
whichever already they were packed together with the help of the
list.
Square braces,
Yeah,
that list notation.
Yeah.
Now they are unpacked and they are given as a totally separate values.
Okay.
Because how we can say, if I do like this, then also the output will be like above. So they are being treated as separate values which are unpacked from the original list.
Okay. Okay.
Okay. But this unpacking you cannot use everywhere. Okay. I mean, I cannot say like this. Okay. I cannot use everywhere.
So basically it works with print function, is it?
Not only print, it works with function calls mainly.
Okay.
So one of them is print, and okay, whichever function will handle that, it works with that.
Okay. Now
okay, for example,
how
print
do we
function
know
has
which function handles that?
No. As of now, print will handle it.
Okay.
Okay, so print will handle it. So that's why I'm able to give that inside the print. Okay.
Okay.
If at all you write your own function, then you need to handle it. And one more thing, it works with any function call.
Okay.
It works with any function call, but you will get an error because that function is not able to handle it inside. Okay, this is something which is happening outside of the function. Okay, what I mean to say is, when you are writing print star of 1, 2, 3, what Python will do is, it will translate this to like this: print of 1, 2, 3. Done. So Python's job of unpacking is done up to this point.
Okay.
Okay. After this, why you will get error is because after these values are being passed, your function is not handling that. So then you will get the error. Okay. So maybe we will do something like this. I'm saying int is a built-in function, right?
Yeah.
So here star 1, 2. Okay, you see what is the error you are getting. What it is saying?
Can't convert non-string with explicit base.
Explicit base means int is actually already tried that.
Yeah.
Okay. Int function has taken your arguments and it tried something and then it is giving the error. It is not a syntax error. It has tried and it gave the error.
So basically it tried, like it created int and in parentheses 1, 2, is it?
Yes. Int of 1, 2. Yes, correct. So let us try maybe.
So same error should come.
So let us do something like this: star 1.
Then it's
okay. So now it is working.
Because it takes single element.
Single argument. Okay. So in all function calls it will work, but the function should be able to handle it after it is being passed as separate things.
Okay.
Okay. Yeah. So the scope is function calls and then list displays. I mentioned at which place of the code we can apply the unpacking. These are all the 4 places. Function calls, list display, tuple display, dictionary display. List display also I can handle it. Means 1, 2, 3, comma, star, 4, 5, 6, like this. You can see what will be the output. Okay. So it has unpacked all the things and it has joined with these existing elements, and you will get the final list of elements. Okay. And same thing.
Can you give some example where we will be doing this unpacking sort of
thing? Yeah, we will use it. I cannot straight away give you an example in my mind, but there are some programs in HackerRank where you'll see this. Okay. It will come through programs. Whichever examples you are asking, I'll give you through programs. Okay. 4, 5. So this is another place, tuple display. Same thing. Last one is dictionary unpacking. Till now we were doing only the normal iterable thing, but normal means simple iterable like list, tuple. But dictionary also we can do it. For dictionary, we have to use only the dict function called star A1 B2. This one, comma, star C3. You can see what will be the output. Okay, so it has unpacked all the things from both the dictionaries, and together it has given a single dictionary. And this is possible only in the scope of dict call. But if I try the same thing inside this one, you can see what will be the result. Okay. A is an invalid keyword argument for print. Basically what happens is it has actually translated this to this one, hash. Okay, so it gets translated to this one. Here it will make it like this. A is equal to 1, comma, B is equal to 2. This is nowhere valid because print doesn't have such kind of keyword arguments. Yeah. But why it is working with the dict? Because we know dict will accept all different kinds of keyword arguments. A is equal to 1, B is equal to 2, C is equal to 3. It will perfectly work and give a dictionary. So that is the thing.
In dictionary we are going to use 2 stars, but in print we use single star because it's a dictionary. That's why 2 stars.
No, it is not depending on this. It is depending on the right side one. This is a dictionary, that's why I'm using.
If we are dealing with a dictionary, then 2 calls.
Yes.
Right.
And when we are dealing with normal list tuples, single star. And one more thing is, why 2 stars is mainly because this is a dictionary, is a keyword argument type.
Yeah,
key and word will be there.
That's why 2 stars. Okay.
That's why 2 stars. Okay. And any place you have the keyword argument style, you can use the double star. Okay. And so this is for the dict. Inside a dictionary also we have seen. Next is, this is also a kind of unpacking, but there is no star or anything. You can call this as unpacking. 1, 2. Okay. So right side is a tuple. Okay. So tuple values you can unpack into a list. So into 2 separate variables. A will get 1, B will get 2.
But here we have not used any star or anything.
No, we are not used it. This is like another another unpacking. We call it as unpacking only, but without any operator.
Okay.
Yeah. Here Python is doing by itself this unpacking into different variables. So if I say like this 1, 2, 3, at that time I can call this as tuple packing. This will only give a tuple.
Yeah, correct.
Okay. And in fact I can do this one. Okay, so this is also possible without any operator. And last, I think this same thing should not work for dictionary. I never tried. and I'm expecting it will not work also. So it is working, but what it has got? Okay, it has got only the keys. Okay, it's not bothering about the values. It is bothering only about the keys. Okay. So these are like the different unpackings possible which we want to do. I mean, if you know this, it will be a shorter syntax.
Okay.
If you don't know this, then it will be a longer syntax. That will make the difference. Okay, next range function. Okay, range function. Okay, range is also an important function which you have to know when you're going to work with the loops. Okay, so if you know now, then later we can start with when applying the loops, we will be directly using the range. Okay. So range is more similar to kind of a slice. Okay, in the syntax wise and all those things. Range is a built-in function. It is a built-in function, but it is better to think of it as a data type. And we can think of it as an immutable sequence type. Okay. Like how a tuple will be there, right? Same way you can think of range as immutable sequence of only numbers. Okay, there is no other scope. It is a sequence of numbers, and it is commonly used for looping a specific number of times in for loops. Mainly we will use the range in for loops. Okay, and range, you can think of it like a generator, number generator. Okay. Because if at all I have to write, for example, if I ask you to create a list with 1,000 elements. Okay. So if you start writing like this, then it is a lot of waste of time. Okay, so you can never write a code like this. So easiest option is range. So I can mention range of, for example, let us take simple one, 100. Okay. So as of now, it will give only the generator. Okay. So it is saying I can give values from 0 to 99, excluding the 100. Okay. It is saying like this. So how you will confirm whether it can give or not? So I can say range of 100, close it. That's it. So we'll get a list. Okay. Nothing for you to do. So it will give by itself. But what the advantage with range is compared to list, it will occupy very less memory. Whether you give 1,000 elements, 100 elements, it will occupy the same memory only. It will only give the values when you ask for it. Okay, what list is actually, list function, what it is doing is, it is actually kind of running a for loop through this range and collecting all the elements what range has given one at a time and putting them into a list and giving the output. Okay, in the background, it is doing a lot of process like going through all the elements one after the other given by the range and collecting into a list. Okay. But ideally, what range will do, it will give only one value at a time. When you ask, it will give. When you don't ask, it will not give. Okay, so that is why in the memory, it will not keep any values. Okay. And advantage with ranges, you can have like different combinations, 0, say let us say 1, you want 1 to 10, and in that case give 1, 11, and maybe you want to give on step 2, so then it will give some like even odd numbers, so you'll get the odd numbers. Okay. So it will give 1 plus 2, 3 plus 2, 5 plus 2, 7 plus 2, like this. Okay. But every time it is like this arithmetic progression. So 1 plus where is this? 1 plus 2, and then 1 plus 1 into 2, 1 plus 2 into 2, like this. It will give 1 plus 3 into 2, 1 plus 4 into 2. Like this it will give. So it is actually the formula here. For a positive step, the contents of range are determined by the formula R of I is equal to start plus step into I. What is I here? I will be the start where it will be the index, first one. Okay. So first element 0, 1, like this. Okay. And start will be the start value. Start value I have given say 1. Okay. Next 1 plus step. Step is 2. 1 plus 2 into 0. So it will give 1 plus 2 into 0 means 1. Next 1 plus 2 into 1, 3. 1 plus 2 into 2, 5. Like this it will generate the number. See, just for our understanding, but you can directly think that 1 1 plus 2, 3 plus 2 like this. It will give the
1 plus
numbers.
2 into, I mean, that's very calculated.
Yeah. Yeah, but a calculation it will do. We have to just understand what is the final output for us. So that is the advantage. See, if you have to generate such kind of numbers by yourself, then we cannot manually type or again do some function stuff. So that is not required here.
Okay.
For a negative step, the contents are still determined by the same formula, but the constraints will be I should be greater than or equal to 0 in that case, and R of I is greater than stop. Instead of going through this, we will go like this. I'm taking this one, I'll put it here. So you can see the output and we'll see what is the direction it is going. So initially start value is -1. Okay. If I add -1 plus 1, it becomes 0.
0. Yeah.
0 plus 1, 1. 1 plus 1, 2. It will never reach
-3, yeah. That's why
gone. So that is why you will get this one.
Yeah.
So next, another example. So here 3 is there. 3 plus of -1. It is anyhow 3 minus 1 only. 3, 2,
1, 0.
1, 0.
Yeah.
Okay. -1 it will not be included. So 3, 2, 1, 0. That's it will give this range of numbers. So here you need not add this length of the sequence, all those things you do not add it. So there is no sequence existing already. So no need to add anything. So you can directly apply the formula like first value plus step, second value plus step, third value plus step, like this you apply. Okay. And whenever when you are giving some negative numbers, it will produce that negative numbers also. Okay. So 0, -10, -1, there it will not add anything. First is 0, 0 minus 1, -1. If it is able to reach that 10, that is enough. So it will not worry about any other things. 0, -1, -2, -3 up to -9. -10 is not included. So negative values also, it will just work like normal formula only. And positive values we have already seen. Okay, in ranges, though we are considering it as a sequence type, it will not be, there is no possibility to do any this kind of things. Range of 10 into, range of 10 plus range of 20, something like this you cannot do. Okay. We cannot do any concatenation or any repetition with the range. I mean, though we are like seeing it similar to list and tuples, it is not possible to do any such those things. Okay, range is like only a generator of numbers. And in range, stop is mandatory. Okay, so without stop, nothing will work. So start, it will take default, but stop is mandatory. Okay. Start default, it will take 0. Step default, it will take 1. But apart from that, stop, you have to give it. Okay. And start value, if you want, we can change. Step value, if you want, we can change. So this will be very useful in for loops. We will see when we are doing for loops also. Next is zip function.
If we do some kind of mathematics like 1 divided by 0, what does Python give in that case?
That will give error only.
Okay. There's
zero
no
division
such
error.
thing like infinity.
No, it will not do those stuff. Okay, so this we will be covering in actually the operators.
Okay.
So this is a note point there. So division by 0 will give division error. Okay. Next is zip. Since we are discussing like lot of iterable lists and all those things. So here we might have a scenario like where we are having two things at once. Okay. So this is, maybe I can mention this as names. Two separate things are there, but you still want to see them together. Okay, so name, age, or age. Okay. So here I can mention 20, 30. Okay, let me use plural only, whether it exists or not, I don't know. So here, if I want to see them together, then what I have to do is zip of names, comma,
ages.
Just a moment. List of, this is also a bit like range thing only, so I have to give it into a list. So it will give like this.
Okay.
Go through both the things at once. So it will do that kind of thing for us. So we need not go. So it will go first element, second element, third like this.
Okay.
Even if you give one more thing also, it doesn't care. So it will give that one also. Tenure is equal to, let's say, 4,5.
Yeah.
So now I can give all the things in one place.
3 it will give. 3 in 1.
3, yeah, 3 in 1.
Yeah.
But the thing is, it should be iterable. That is important.
Okay.
Okay, I mean, I cannot give like tenure is equal to 1 integer and put that tenure there, it will give error.
Okay.
So there is a star, that's why it's given star. If I don't give anything also, should still work. Okay, let me give like this. It should give some empty thing. Okay, so it will give empty.
Okay.
Because I have not given anything to iterate, so it will give me empty list.
So by default, it will always create list, not tuple.
No. I am creating list.
Okay.
It will just give an iterable kind of thing. I can put that iterable into anything.
Okay.
So I can make it like this also. Tuple, zip.
Yeah.
This is also okay.
Yeah.
Okay.
Okay.
Why? Because these range and zip, these are not straight away giving the full iterable for you. They will keep the values with them. You have to collect them into a container kind of thing like list, tuple, those things.
Yeah. Okay.
And there is another option, strict is equal to false. What is the use? We will see. By default, zip will stop when the shortest iterable is exhausted. For example, there might be a situation where people might give more values in one and lesser values in another.
Yeah. Suppose 3 names and 2 age.
Yeah, and we are giving like this. So in that case, what will happen? So at that time, it will simply ignore the leftover ones. It will only consider the shortest iterable.
And Sham. And Mark it will ignore. Oh.
Ignore. Okay.
And then no warning as well. So no warning as well that it has removed Mark.
No. At that time, that is the advantage. We have strict keyword argument.
Okay.
So here it is saying zip is often used in cases where iterables are assumed to be of equal length. So we are generally assuming equal length. Okay. So in such cases, it's recommended to use the strict is equal to true option. Its output is the same as regular zip, but unlike the default behavior, it raises a value error. So at this time, now we can apply the same thing, but with I have to pass strict is equal to true. To argument 2 is shorter than argument 1. Yeah, that's what it's expected. Value error. So it is saying argument 2 is shorter than argument 1. Argument 2 was ages. So ages is having 2 values. Names is having 3 values. Okay, maybe if we reverse it, then it will say argument 1 is shorter than argument 2. Without the strict is equal to true, this is very useful when you want to find the problems. With a single iterable argument, zip returns an iterator of tuples. Okay, this one we can actually see later when we are discussing about iterators. So here, I'm sending only thing. So it will again list of zip of, whatever is there, it will return the same thing. Here in this case, it will not actually make any sense in this. So zip of 1, 2, 3, it is collecting all of them. But though it is not having the second value, it is still making tuple. What we did, everywhere it is making the tuple. So here also, though you don't give the second value, it is making a tuple. Okay. Irrespective of whether you have or not, it will give a tuple. Iterate of 1 tuple. Yeah. So it returns an iterator of 1 tuple. So single element tuples it is giving.
Okay.
So this is all about the zip. Next topic is operators. We start a bit the operators. So operators, only one thing I have. That's See, in operators, first thing is we will see what are expressions. Okay, so expression we are saying sometimes like this is the expression kind of thing. So what is expression? Expression is a piece of syntax which can be evaluated to some value. Finally, it should be evaluated to some single value. In other words, an expression is an accumulation of expression elements like literals, names, attribute access, operators, function calls, which all return a value. Means there are a number of possibilities in expressions. So some examples can be, okay, so if I am saying simple expression is this one. Okay, this is the simple expression. Now in this, what are the literal parts? 11 is a numeric literal, 23 is numeric literal, and the plus is the operator. So we are satisfying this particular thing. So we have literals, we have operators. Okay, so expression can consider any of these elements in any, in any number. Okay, it is not mandatory to give in a. So other ways, identifiers. A is equal to 11. Now I say 11 plus A plus 23. So here A is the identifier. So whatever.
So it will always be numbers. Can't it be
sorry,
like
not
A plus B?
Names. Yeah.
Can't it be A plus B?
We can do, but B should have some value, na?
But it always needs to be number for expression.
No. You can string also.
Yeah.
This is a string literal. I say this is a string literal. I say this is a numeric literal.
Okay.
Literal means that simple value.
Okay.
And here another thing is literals we have checked. Names means identifiers. This A and B, whatever were there, right? This above A. This is the name. Okay. Names we have seen, literals we have seen, operators we have seen. And next is we have also attribute access and function calls. For example, attribute access and function calls. I can take this example. Because sometimes we might think that this is not an expression, but this is also an expression. So here, int of 1 means what value it will give?
It will give 1.
1, yes. And next, what this one will give?
Hello dot count of 1 count.
Count of L.
Count of okay. Count of L. That will be hello dot 1. It will give hello dot. It will give H. No. Sorry. Count of L. Sorry. 2. Yeah.
2. Correct. 1 plus 2, 3.
Yeah.
So that will be the output. So expression can include. I will say this is the attribute access, because what I'm accessing a method of a string object.
Yeah.
This method I can call as attribute also. Okay. So this method I am accessing the return value from this method, and I'm also accessing a function call.
Yeah.
So those also we can put inside the expression. All these are valid. These all are called expressions, and we will just, these all elements can come inside the expression combined with some operators and those things. Okay. So there are some things like while and those things. Those we cannot call expressions. Those we call it as statements, while statement, if statement. And expressions are only these things: literals, which have literals, names, attributes, operators, function calls, which all return a single value, not the statements which is a block of code. Those we cannot call as expressions. Okay. Even the assignments are also statements, but not the expressions. Assignments means A is equal to 3. This we cannot call as expression. Okay, this is just an statement.
Yeah.
Okay, we will see later what is exactly statement and different statements. Arithmetic operators. So now we are going to deal with operators, because when we are dealing with operators, mostly we'll come across all the different expressions. Everything, whatever we do with operators, we can consider them as expressions. Okay. When we are dealing with operators, main thing is we have to just understand what is operator, what is operand.
Okay.
Operator means the symbol, the plus, minus, these are all operators.
Okay.
Operand means the value or the object on which this operator will do some action.
Okay.
The objects or values on which an operator acts upon are called the operands. Okay. So because operator has to do action on some values only.
Yeah.
So we will mainly start with the numeric values. So in that, we are considering with we are starting with arithmetic operators. But for understanding arithmetic operators, we have to first see what is arithmetic conversion. Because see, whenever I say number, it is not necessary that I always give 1 plus 2. This is also a valid mathematical operation.
Yeah.
Correct? 1 plus 3.4. So it should support either 1 plus 2 or 1 plus 3.4. Anything should be possible.
Yeah.
So in that case, how Python should handle, whether it should consider the integer as the importance or float as the importance in the final return type. See here it is considering what return type? Float.
Float. Correct.
Okay. So why it is doing like this? That is a description with respect to arithmetic conversion. So whenever you are reading some phrase like numeric operands are converted to a common type. Okay, if you read like this, then what is the meaning of that? Common type, what is that common type? If either of the operand is a complex number, the other is converted to complex. This is the first priority. Okay, if any of the operand is complex, then convert it to complex, final thing.
Yeah.
Okay. Second priority, if any of them is a floating point, then convert to floating point, entire thing. Okay. Third priority, both must be integers and no conversion necessary. Means what it will do is, it's when like I'm saying 1 plus 3.4, it will translate this to 1.0 plus 3.4 and then perform the operation. That is the final, that is why you will get the 4.4 as the output.
That's one way of understanding, but it's simple maths, right? In maths also we do like this only.
Yeah, simple maths, yes, but Python is taking care of everything for us. Yeah.
I mean, one way is like reading this, it converts it into first this.
Yeah. Because there should never be like thinking like we can again come back and say 1 plus 3.4, why can't it make only 4? So that doubt should not be there.
Okay.
And next, addition operator. We are already seeing a lot of times. It gives the sum of the operands. So operands can be two types in addition. So we have covered both already. Numbers means numbers will be converted to common data type. So common here is float in this case.
Float, yeah. In this case, it's float.
And then added together. That is correct. And sequences of the same type. This also we have seen like string plus string, list plus list. So this is another thing. Okay. And next is subtraction operator. Subtraction operator, no possibility with other types because there is no subtraction for strings or any other type. So we have to do with numeric things only. So 4 minus 1, return the sum of things. 4 minus 1.8. So float. Okay. So final output will be like this. Yeah. And one more place where we are seeing minus is sets.
Okay.
Not in lists or any place, only with sets. So that is why we don't have any other sequence, any stuff like for lists or something, we cannot do anything. So minus 1, it will not give anything. Okay. So minus will work only with numbers, and the other exceptional part is only sets. If we can use the minus operator.
Okay.
Multiplication, we have already covered. So it will cover two numbers, multiply.
Yeah.
One sequence and one number, do a repetition.
Yeah, 1 into.
Okay.
Yeah.
So that is the earlier thing. So,
that we
yeah. So with this point we will stop, and this true division it will take some time to explain. So this one we will start from tomorrow. Okay. Okay. Yeah. So yeah, end of the day I'll put it. So you are working. You will work on all the assignments in the weekend, right?
Yeah, I will do it on. You can put the assignments. I will keep.
Yes. I am putting every day like one, whichever based on the topic. So to solve that.
I think you can give the assignment from the day-wise topics that we have covered.
Yes.
And then for the weekends as well, I will try to devote weekends because weekends I have more bandwidth available. So.
Okay.
Yeah.
Okay, so I want to see like how you understand the additional part.
Sure.
However, if you are not understanding, that will be clearly discussed in the class.
Discuss definitely. Yeah.
Okay.
Sure. Okay.
Okay then. Yeah. Okay. Then we'll stop for today.